When we hear aging, we think disease, but it doesn't have to be that way. By 2050, 27% of the world's population will be 65 or older. This will create extra pressure on healthcare systems all around the world, as there will be more people suffering from age-related diseases. Living cells respond to damage through a process called senescence. Senescent cells, also called zombie cells, are half dead, no longer able to divide, or perform their normal functions. Senescent cells normally get cleared away by the body, but if they don't, they can sit there and wreak havoc. They release inflammatory molecules that cause their neighboring cells to turn senescent too. This process leads to creation of senescent cell clusters, which we know are linked to diseases such as Alzheimer's and cancer. Studies have shown that clearing away these clusters can improve the lifespan of organisms such as mice. Researchers at Fruc Lab at the University of Cambridge are at the forefront of senescent cell research.
So NanoJAGGs are our nanoparticle system we made, and they're made of an FDA-approved dye, which is really cool. So that means it's safe for human use. But then as we self-assembly these into more nanostructures, we found that these can actually target senescent cells and accumulate selectively inside of them. We first inject them in, we then wait for around 6 hours, and then after that we use photoacoustic tomography to read the signal out. It uses laser light in to excite molecules. The NanoJAGGs act as this molecular antenna. And then once we use the correct excitation light, we get a huge ultrasound signal that we can read. And this has a lot of benefits because it's more, like the penetration depth is much more than previous techniques, and it also has higher resolution.
Nanotechnology is playing a huge role in healthcare, and this is going to continue. It is very important for development of contrast agents, particularly in early diagnostics for diseases, cancer, neurodegenerative diseases. And we believe that our technology, our NanoJAGGs contrast agents, will help us not only in fundamental understanding of aging, but also in patient stratification. So by exploring how much senescence we have in a particular tissue, we can also develop technologies to say which patient reacts well to a certain therapy and which doesn't. So we can adjust those therapies in the clinic. And not only this, we will be able to follow the course of treatment, and particularly in cancer, and also develop more efficient strategies by which we can, turn diseases like cancer to be chronic diseases, but not terminal diseases any longer.